36b is the sums of trigonometric functions, and sometimes it's useful to be able to add up different trig functions to get their summation. This is going to be the problem 36.1, which is evaluate the cosine of 135 plus the tangent of 330. Now I've gone ahead and pre-drawn, I have two different xy coordinates, and I'm going to label this one the cosine of 135. In order to get that, I'm going to go ahead and say, well, this would be 90 degrees, and if I came over here, I would say that would be about 135 degrees. That's going to put me into the second quadrant. I drop the leg down here and realize that if this is 180 all the way, 180 minus 135, and that's going to give me a 45-degree angle inside. I do the same thing on the tangent of 330, but remembering that this is going to be 90, 180, 270, and 330 is going to put me into this quadrant here. And I purposely did not draw exactly where that was because I don't know exactly where 330 would be until I realized, oh, this is a 30-degree angle here. Okay? And my drawing is not going to be very perfect as far as the location, because I was estimating where 330 was. This will happen to you quite a bit as you're drawing. This one is actually closer to 45 degrees. So once I know that should be 30 degrees there, I'm going to go ahead and back that out and say, okay, let's make one that would be actually a little closer to that. And there's my 330, which is going to give me an inside angle of 30 degrees. Now, at this point, I'm ready to go ahead and say, well, what is the cosine of 135? I'm talking about cosine, so I have an interior angle here of 45, and I'm looking for a cosine of a 45. I put my reference triangles up over here. You should be able to draw these from memory at this point with a 45, 45, 90, and I didn't label that there. 45, 45, 90, and a 30, 60, 90 triangle. 1, 1, root 2, and 1, 2, root 3. This is my 45-degree angle, so I'm looking for a cosine of an angle, 135. So my cosine function is adjacent over hypotenuse. Well, the labeling this is going to be very simple because this is a 1, 1, root 2 triangle, and my cosine, therefore, of 135, as the same as the cosine of 45 in the second quadrant, is going to be adjacent over hypotenuse. So that's 1 over the root of 2. Now, at this point, I have to be very careful because I've realized that cosine in my second quadrant, all students take calculus, cosine in the second quadrant, this one here is technically a -1. I'm going to have to remember that's technically a negative. That accounts for the 135, and that puts me in the second quadrant. The next option that I'm going to do, or the next part of this problem I'm going to do, is I'm going to take the tangent of 330. 330, once again, is a 30 degree. I look at my special triangle here, my reference triangle, and I say 30 degrees. I'm looking for tangent. I have to remember that tangent is opposite over adjacent. So if I go to my 30 degree and I say opposite over adjacent, 1 over root of 3. There's another little problem here, and that is that when I look at it, I realize that in this quadrant, my opposite and my adjacent, my opposite is a negative, my adjacent is a positive. A negative divided by a positive is a negative. Now I'm ready to go ahead and move these and say -1 over the root of 2 minus 1 over the root of 3, substituting them into my original problem. I'm almost done, except that I have another issue here. I can't add these, they don't have like denominators. And I have a secondary issue, which is that they both happen to be with a square root in the denominator. In order to do that, I'm going to multiply the top and the bottom by the root of 2 and get negative root 2 over 2 minus, I'm going to do the top and bottom by the root of 3, and that's going to give me the root of 3 over 3. I need a common denominator here to do this. My common denominator is going to end up as 6. In order to get this to be 6, I multiply the top and the bottom by 3 and get -3 times the root of 2 over 6 minus, I need a common denominator here. I multiply the top and the bottom once again by the common denominator of 6, multiply the top and bottom by 2 and get 2 root 3 over 6. I can now combine these and say -3 root 2 minus 2 root 3 over 6. At this point, I would be done, except that I realize I have a common that would cancel if they were separated. They can't cancel here because, once again, I would have to be able to pull the same term out of both to cancel them out, and that's going to be my final answer.